Ever found yourself waiting for customer services reply? Let's see how we can build a bot for that specializes in these kind of work for the company. Today, we are going to make a specialized chatbot using pure deep learning. No Google's API or Gemini or any kind of large language models. Let's get to it. So, why steer clear of these big LLMs? Because while they are capable, they often generate unpredictable replies that can risk your company's reputation. Our solution? A chatbot built from scratch, designed to be precise, controlled, and focused on delivering consistent responses. This bot isn't just for show. These kind of bots are used in various companies that can boost customer support, guide users through your products, and handle real-time FAQs with total reliability, all while staying aligned with the company's standards. So let's get coding. Firstly, we will set up our Google Colab notebook for training our chatbot. For this, what we'll do is we will come to colab.research.google.com and then create on a new notebook, and that's it. That's the whole setup required for this chatbot to be trained. Now, we will train this chatbot onto our intents file. This JSON file contains tags, patterns, responses, and contexts. The tags are the purpose of those patterns for which it is used. Then the responses are the messages that the chatbot will give. As I said, we will be using pure deep learning and not any text generating like LLMs like Gemini or OpenAI. For that, we have to provide these kind of things. So you can find this file in the description of this video, and let's get moving on. So we will just take a look at workflow of this project. Firstly, we will import the necessary libraries. Then we will download the required NLTK packages. Then we will set up Lematizer. What Lematizer is, I will get to that later on. Then we will use our intent file to extract patterns from the text that we have provided into the file. Then we will save those patterns into a pickle file. Then we will train our model to that data, and then we will just save the model. That's it. That's the whole process. Then we will work on the Flask app, and then we will deploy it to a server. Let's go. Firstly, what we will do is import the necessary libraries. So import the necessary libraries. What we will require for this is firstly, I'll just set it up. What we will require for this project is first we will require random, then JSON, then pickle, as well as NumPy, TensorFlow, and NLTK. So import NumPy, import TensorFlow as TF, and import NLTK. That's it. Let's run this cell, and we have let's run this cell. Then what we will do is download the required NLTK packages. Now what we'll require is we will require PunKT for natural language understanding, and then WordNet for creating Lemmatizers. So let's get into it. Firstly, I'll just comment it down. Downloading the NLTK packages. We'll download WordNet as well as PunKT. So nltk.download. We'll download PunKT. As well as WordNet. So it has done downloading. Then we will import WordNet Lematizer from nltk.stack. So import Then we will import wordnet lematizer from nltk.stem. So from nltk.stem import wordnet lematizer. What does a lematizer do? Lematizer, just in simple words, removes the suffixes and the prefixes of a certain word, makes it transform into a machine understandable word, like in its basic form. What we will do is, suppose there is a word is called changing, changes, change, changed. It will convert all those words into its base form, that is change. So that's basically what lematizer does. So now we will initialize that lematizer. Initialize the lematizer. Now what we'll do is lematizer equal to word net lematizer, and we will initialize the basic form of that. Then we will load the import file, intents file. So intents equal to json dot loads with open our file name is intents.json dot read. That's it. We will run it. After that, we will create empty lists for words, classes, and the documents. So words equals to an empty list, then classes is also equals to an empty list, and then documents is also an empty list. That's it. So now we will define a list of the characters that the lematizer should exclude. Like, for example, any exclamation marks, any full stops, as well as some commas that might not give a certain significance to the lematizer as well as the chatbot. So we will just ignore those and we will create a list of that. So create a list of the symbols, let's say, to ignore. Then ignore letters equal to a list of, this will include a question mark, then an exclamation mark, then a full stop, and a comma. That's it. Go down here. Okay, that's done running. Now, what we'll do is we will look through all the intents and extract their features. Okay. So now what we'll do, we will extract features from the intents by looping through them. Looping through the intents and extracting the features. So for intent, in intents, and there also intents. Okay. Then again we will find patterns of each intent. And for pattern in each intent, that is intent of patterns of intents. I'm sure this might be confusing for you for now, but it will get better with the times. So now what we'll do, we'll tokenize each pattern. So now and we will store it in a word list actually. So first we will tokenize it. So word list equals to nltk.tokenize word tokenize. We will tokenize the pattern. Okay. Now we will append that word list to the words list that we have defined up here. So we will get that. Now we will just extend it. So words dot extend with word list. That's it. After that, what we'll do is we will append the same word list and the tag of that intent to the document section. So documents dot append. What we'll do is word list and the intent, tag of that intent actually. So there. Now we will add the intent tag in the class if it's not present. Okay. So there are multiple patterns as well as multiple responses. That's why first we have to check and then add. So I'll just add a comment. Add tags into the classes file if they are not present. So if intent of tag of intent not in classes, classes.append, we will just append it. What will append with the intent stack. Okay, done. That's it. Let's run this and it runs successfully. Then what we'll do is we will lamentize the words and remove the duplicates. So we'll just create the word list again and we will use list comprehension for that. So lamentize the words and remove duplicates. Also ignore letters. So what this will do, this will lamentize the words. The words will be in their basic form then, and then it will just remove the ignored letters from that list. So words, we will reinitialize it. Words equals to lamentizer dot lamentize. What it will lamentize the word for word in words if word is not in ignore letters. This will, okay, so this will lamentize the words if they are not in the ignored letters. What are ignored letters? These 4 things are the ignored letters. They do not make any significance for the chatbot. That's why we have removed it. So let's run this. It is working fine and it has run successfully. So now what we'll do, we will make pickle files of those words as well as the classes. But for that, they should be in the sorted order so we can use it for training data. So now words equals to words, sorted, and this will be a set of words. Why so? The set doesn't contain any duplicates as we know, and so it will not get any redundant data in terms of chatbot training. Okay, same we will do with the classes. The classes do not contain any duplicate data. Still, we are doing this by any two-factor authentication method. Always, it is safe to do that. Now we will dump these classes and words into pickle files. Pickle.dump words will open a file called, let's say, words.pkl with the right bind. That should be in inverted commas. Yeah. Also, we'll do the same with classes. We'll open a classes.pkl and done. Same, simple. Okay, so now what we have is a words file as well as a classes file. Now what we'll do is we will create the training set. So for now, let's create a training set. For this, we cannot have any validation set since we have to create every intent for the chatbot. Like the chatbot should answer every question that is present in the intent. It should look at those files actually. That's why it doesn't contain any validation data. We will just use the training data for now. And it is actually a good thing to pass it every single data that you have. So training equals empty list. This will be our training data and the empty output. Done. So we will, after creating the training data, we will create an output file, an empty output file containing zeros of the length classes. So the empty output equals to list of zeros of the size length of classes. That's it. Now what we'll do is create a bag of words representation for each document. So remember what documents are? Documents are the tuples of word list as well as intent, tag of the intent. I hope you have got that. So let's create a bag of words representation. So we'll loop through each document, then document and documents. There is an empty bag. Okay, so word patterns equals to the document 0, then word patterns will be equal to, now here, list. We will create a list of lemmatized words in each word pattern. So lemmatizer, there's a typo, lemmatizer dot lemmatize each word. We'll just keep it to a lower. This will convert all the words into lowercase, and then we'll do for word in word. Okay. Also, for word and words, bag dot append. So this will create a bag of word. Bag append 1. So where word is present, the bag will be 1, and where word is not present, it will be 0. Then let's append 1 if a word is in word patterns, else we will append 0. Bag dot append 0. Okay. I guess this is done. Let's run this. Done. Let's check the bag. For that, so now we will create the output row. So let's create the output row using our output row list as well as the bags we have created. So now the output row will be equal to the the list of empty outputs. Then the output row of that exact class. So I guess where is the empty? Yeah, it is empty output and not empty outputs. So the classes, each index of those classes, the first index, like the document of 1 will be equals 1. Yeah. Then we will training and we will append this to the training, the bag as well as the output row. Done. Let's just run this. Okay, done. So now we will shuffle the training data so that redundancy does not occur as well as the model does not get biased towards one. Okay, so then let's shuffle the data using random. Shuffle the data. Random dot shuffle. Okay, we'll shuffle the training data. Then training will be converted into the NP array. NP dot array training. Then okay, didn't we just put numpy as okay. Done. So let's convert it into an NP array. So now what we'll do, we will create the xtrain and ytrain data. We will separate the labels as well as the sentiments. So the x train will be equals to training of len words, and then the y train will be equal to training of this colon and then len of words, and then at last the colon. What does this do? This will separate the responses as well as the intents, like tags. Okay, let's separate. No, let's say create x and y for training. Let's run this. Done. Now we will create, this is a fun part. Okay, we will create a neural network using TensorFlow. That neural network will contain some dropout layers, an input layer, as well as activation functions like softmax and relu. Let's see how that goes. So create a model, sequential model actually. So let's create a sequential model using TensorFlow. So now model equals tf.sequential. I guess I have spelled it correctly, but the S is capital. That's it. Then we will add the input layer to the model. Then model.add. What will add is tf.keras .layers .dense. It will contain 128 neurons as well as the input shape will be equal to the length of x train of 0. Done. Then outside here, like this. Then the activation will be equal to relu. Again we will add a dropout layer, then again a dense layer, again a dropout layer, and lastly the output layer. So let's add. So model dot add tf dot keras dot layers dot dropout. We will get a probability of 0.5, so the model randomly turns off 50% of the neurons of that layer. So this will help us overcome overfitting as well as train the model efficiently. Okay, so again we will add the dense layer, model dot add tf dot keras dot layers dot dense. This will contain 64 neurons and the activation should be again relu. It's not RF, it's TF, my bad. Again we will add model dot, let's copy from here, a dense layer, sorry, a dropout layer. And again we will add a dense layer, model dot add tf dot keras. I always spell keras like badly. Dense, and this will be the output layer, the length of y train 0. And again this time the activation will be softmax since we are working with multiple classes. So softmax will be the output function, like activation function. So that's our model. Let's run it. Sorry. What have I done wrong here? One change here, we have to do tf dot keras then dot models. And then sequential. Dot keras. And this should be models. Yeah, done. Okay. So now what we'll do, we will compile the model. So let's compile the other model. So what we'll do is we will use the SGD optimizer for this stochastic gradient descent. What stochastic gradient descent does is it uses random values as per our learning rates and then again train our model to get the lowest gradient possible in that training plane. Okay, so let's see. We will use sgd equals tf.keras dot optimizers dot sgd. We will set the learning rate to 0.01. It should be equals to, okay, and then we will set the optimizer to sgd. Then again we will set the momentum it should not contain the optimizer. Okay, we'll set the momentum to 0.9 and again master of to true. It should be 0.9. Done. So now what we'll do is compile the model. So model.compile loss equals, since we are dealing with categories, the losses should be categorical cross entropy. Let's set up categorical cross entropy. Again we will use, here should be the optimizer equals sgd. Then we will use matrix as let's use accuracy for now. Let's compile the model. This is n here. Okay, done. So model is done compiling. What we'll do now is train the model using we will use 200 epochs for now, and then we will use a batch size of 5. Let's see. Train the model. So we'll plot the history. We'll save the history. Model.fit. And we'll call the we'll pass np.array of xtrain as well as np.array of ytrain, and we will set the epochs to 200, not 0, it's 200. Then the batch size 5, and then verbose 1. So model is now compiling. What the verbose does is it shows us this process, the title bars, the progress bars and all. If we have set it to 0, then it does not show us anything. So model is done compiling. Let's check. So as you can see, we have trained the model considering 100% accuracy. Why it is 100%? Because we have provided the whole data to the model, as well as it does not do any validation, since we have to train our chatbot on all the data that we have prepared for it. We don't have to test anything for that. Okay, so now let's save the model. Let's save the model using an h.h5 method. Okay, so why we will save it? We will save it to use in our Flask app. We will just develop the Flask app later on. Okay, so now let's save the model using model.save, and we will pass the name bycard customer service chatbot. .h5, and we will pass it the trained data, the history and then we will print done. Okay, done. So now it is giving a warning that we are saving our model as HD5 file instead of the Keras format that they recommend. It doesn't have any issues with the Flask app, so we will just use the H5 variant. So here, as you can see, we have the model PyCart customer service chatbot. So now I encourage you to download all these files and then store them into a directory that I'll show you how. Then let's get to the Flask application. Let's meet you there. So as you have built the chatbot now, let's build the web application for that in order to deploy it on a server. So we are going to use service called CoWeb in order to deploy it on the production servers. For that, we have to build a Flask app. In order to deploy, we need all these files, the words.pkl that we have created, the classes.pkl, as well as the intents, as well as the model file. The static and the template files, the index.html for this project will be found in the description, and CSS file will also be in the description. So let's build an app.py file for this project. So now in our repository, let's just initialize a file called app.py, which will contain the Flask code. Now we will just do the imports of the required file. So importing the required modules, the same modules that required for our chatbot will be required here, but additionally we will require Flask, the render template, as well as the request module, not the redirect, request module, I'm sorry, and the JSONify. Okay, then we will import a random as required on our chatbot model. Okay, then JSON separately, as well as pickle, then NLTK, NumPy, TensorFlow, and the load model function from TensorFlow Keras. So NumPy as np, import NLTK, then import the WordNet lematizer from NLTK. It should be from NLTK, import WordNet lematizer, and then from TensorFlow, not TensorBoard, from TensorFlow.keras.models, import the load model function. Okay, so now what we will do is we will import the necessary packages from NLTK. We will just download them. So download the NLTK packages. For this project, we will require PunKT. As we already know, we will require WordNet. Additionally, we will require PunKT_tab in order to work with NLTK on our deployment servers. That's the requirement from CoWeb. So we will just nltk.download PunKT. Then we will download the WordNet. Before that, we will download PunKT tab, and then lastly WordNet for the lematizer. Okay, then we will initialize the Flask app. So app equals Flask __ name __. That's our Flask app. Then we will load the data and model. So now there are 4 things we have to load. So the lematizer, we will just initialize the instance. I hope I spelled it correctly. So wordnet lematizer, that should be it for the wordnet lematizer. Then the intents will be recorded in a JSON file. So json.loads. Then we will open the intents.json file and we will read it. .read. Okay. Then we will read the words using our pickle file, pickle.load. Then we will again open, what's the file name, words.pkl in the binary. So read binary. Same thing with the classes. We will just replace the words with classes. So classes.pkl. That's it. And lastly, we will just import the chatbot model using the Keras load model function. Load model. Our model's name is PyCart customer service chatbot .h5. Now what we have to do is we have to make some functions in order to do that. I'll just close this for now. Okay, so let's define 4 functions. Firstly, we will define a function for cleaning up the code, like the sentence. Okay, so that will be def, let's say clean up sentence. That will take the sentence as the parameter, and then we will just tokenize them using the NLTK library. Then the sentence words should be equal to NLTK.word tokenize, not word tokenize. We will tokenize the sentence. Then we will just lematize it. Lematize. So the sentence words, again we will use list comprehension for this. The lematizer dot lematize. What we will lematize? The word dot lower. What is word here? Let's define it. For word in words. Sorry, sentence words. That should be it. Then we will just return the sentence words. That's it. That's the first function. And these squiggle lines are there because this is a Git repository that I have initialized in order to just deploy this on production servers. It will save my time, and you should always write your code in a GitHub repository. If you run into an error, you can just go back to the previous commit also. Okay. So now we will define a function in order to create bag of words. Function to create bag of words. So def bag of words. Always this. It will all again take the sentence. Sorry. Now the sentence words first we will take using the function that we just defined. We will clean up the sentence and pass the sentence to it. Okay. Then we will create a bag of zeros, a list that it will be list of zeros of the length words. Okay. Then let's create bag of words, BOG. Then for W in sentence words, And then for I comma word in enumerate of what will enumerate the words. Okay. If the word is equal to I, word is equal to I, my bad, my typos. Okay, we will just set that index of that bag to 1. Index of I to 1. Okay, not the semicolon here, it's the C++. And lastly, we will just return the numpy version of this. So np.array, what we will return the bag. Okay. Now we will create a function to predict the class of the sentence. So firstly, what we will require for this is again the sentence, and we will call the functions again and again. So now we will actually call the bag of words function here. Then we will just set up, let's comment it out first, function for getting class. Okay, then def predict class, which will again take the sentence, and we will call the bag of words function here. So bag of words, we will again pass the sentence there. Then we will get a result using the model's predict function. So our chatbot model.predict, what will predict the np.array. Let's predict the bag of words and take its 0th index, okay, like the result. Then we will define an error threshold. It should be in all caps. Threshold. So our result will be there only if the probability of that result passes our threshold. So for now, we will just define 0.25 for our threshold, since we have trained our model on our whole set. Okay. So now let's filter the prediction in the descending order. Firstly, we'll just filter the prediction from the above threshold. Filter the predictions using the threshold. Okay. So now the results will be equal to, it will be of two things, the I and R, which are those for I comma R in enumerate of, what is it, the result that we have just got from the model if the R is greater than the error threshold. So that should do it. And let's sort them. Sort the results in descending order. So the maximum probability will be on top, and that should be the reply that we are getting from that chatbot. So in descending order, results dot sort. Let's sort using the key equals to lambda of x for x of 1 in the reverse order. So this should sort it in the descending order. We will now create a return list that will be returned. It will be an empty list for now. Now we will create a list of intents and probabilities. List of intents and so this is the list of probabilities and intents. So we will just look through it for R in results or res in results, whatever you may like. since we have used res already, I have used R here. So return list should be appended, not append. What will be appended? The intents, okay, as classes of R of 0 and the probability. Probability will be string of R of 1, and that should do it. Yeah. So now we will return the list, sorry, the return list. Yeah, I just got and lose it there. Okay. So that's the whole function for predicting the class. It is one of the finest and one of the trickiest function that we have created today. So now the last function, which will be getting the response from the chatbot. So get the response from chatbot. Okay, so let's create a function for this. Get response okay, and we will again, this time we will pass the intent list, intents list, yeah, if I spell it correctly, and then we will pass the intents.json as a file. Okay, so the tag, we will first get the tag of the intent. So intents list of 0, and we will get the intent, the tag from the intent. Okay. So list, also we will create a list of intents, yes, from the intents.json. So it will be the list of intents from the JSON file. Okay, this should do it for now. And now let's search for the matching intent tag. Using for loops. We are writing a whole lot of for loops. So in list of intents, yeah. If I of tag, so the tag matches our currently gotten tag, sorry, currently retrieved tag, not gotten, it's not a word. So we will choose a random response from the set of responses. From set of responses. Okay. So here we will require random. So result equal to random dot choice, and we will do I of responses. Okay, that should do it. And after getting one response, we will just break the loop. We don't have to search again, and we will return the result. That should do it for the functions. Now we will create the app roots. The app roots are defined using the @ symbol, then the app's name, that is app dot again root. We will define the initial root, that is for home directory, and define a home function for that. That will just return the rendered template, which is I guess our index.html. That should do it for the home directory. And now let's define the root of chatbot. Okay, so app.root again, and what we will do is we will define /chat, and we will define a method equals to, it will be a post method actually. Yeah, that should do it. And let's define a chat function for that. that will get the user message in the sentence, let's say, that user has provided. And user message will be equal to request. We will use request.json.get. And we will get the message. Okay. Now we will predict the intent. Let's search for the intent. So int's equal to predict class of user message. Then we will get a response. It's just like a pipeline, although it is not a pipeline. We will use pipelines in our future projects. So stay tuned for that and subscribe to the channel, and make sure you hit the like button if you have enjoyed this video. Okay. So now let's get a response. So res should be equal to get response, and we will pass the ints as well as the intents. Now return the response. Return JSON file that will be handled by JavaScript in our front end. This should be in the inverted commas, I guess. So the response, let's make it double inverted commas since we are using it. Okay, let's return the res as JSON. Now let's run the app. So if __ name equals main __ main, and we will run app.run. What we will do is we will use the debug mode. Debug equals true. Okay, so that's the whole app code. Let's save this. Let's open it in terminal. So let's run the app. So py app.py. You should run this command in the root directory of your project. And the app is currently running on the server, not the server, on the local server actually, HTTP 127.0.0.1 on the port 5000. If we click here and if we drag this, okay, as you can see, we have our bot running. So if we say hello and send, we should get a response back. So there's a slight key error. Let's see where. Okay, the intent, I guess somewhere around here I have messed up. So let's check. Things like this happen actually. The tag, it's intents list. So I actually found the error here, and what I did was, when I passed down the intents and probabilities, here I said intents, and when I called the tag, I said intent. So here I should do intents, and then again if we save and then go to terminal and say py app.py and run this, we should get the app running now. So once you go here, this is the old one over. Okay, and let's say hello and send it. We should get the response back. So yeah, that's the whole app done in our local machine. Now let's deploy this on the production servers. Let's see that. Now that we have built our app, let's deploy it on the production servers using services like GitHub as well as Coeb. Coeb allows you to drop your apps on the production servers using nothing but just two files, requirements.txt and runtime.txt. It doesn't require any money, although you can just buy some instances, like a small instance or a nano instance if you want, at the cost of like $5 or $3. I don't know. So let's get into it. So for this, you will, as I said, require two files, a requirements.txt and a runtime.txt. So this requirements.txt contains all the packages that requires for this app to be run. And lastly, a Gunicon. Gunicon is a package that Coeb requires in order to run your app. So if you face an issue while deploying, just assign your TensorFlow version to 2.16.2 and assign your runtime to 3.11.6. That way. The Python version will be same. It might be your system version, doesn't matter. Just don't go above 3.11. Just don't go 3.12 since TensorFlow doesn't work on that. So now let's go on to GitHub. As you know, these two files will be required. Push all your project files onto the GitHub. So as you can see, we have the Git repository for this project already implemented. And you can keep the repository private, although I have kept it public for research purposes. So now if you go to app.coeb.com and log in, you can see an interface like this. So click on web service, GitHub, then connect your GitHub here. There will be an option. Then click on your repository that you want to deploy. In here, you can select a free instance, although I'll select a small instance. Then let's click on next. And lastly, in the regions, select Washington DC. Although Frankfurt has low latency, it sometimes creates problems. And then export your project on the port 5000, expose it, and in the build pack, just override the run command as Gunicon app:app. That's it. And once you deploy, there will be an instance here. Although the URL will be something gibberish, you can just adjust it later. I'll show you. If we just go into here and check, it is already done with cloning the repository and analyzing. Now it is initializing the Python runtime and installing the required libraries that it wants, that Coeb wants in order to run your app, as well as the Gunicon. As you can see, all the packages are getting downloaded using pip. And let's see. As you can see, they are currently building a runnable container of your application, like our application source code. So let's see how long it takes. Currently, it is installing the collected packages that we have initialized in the requirements.txt in this file, as you can see. Okay, since we don't have any corpora established for NLTK using nltk.txt, they are not downloading it currently. They will be just using the words and classes file that we have provided, the pickle files. Okay. So in the backend, Coeb works on Heroku. That's why it is adding some Heroku layers, like profile layers, then shim layers. You'll see. Using Coeb, it is easy to manage the metrics as well as the console if you are already having it. Currently, it's not available since the instance is not created and not deployed currently. Currently, it is just on the export. Then it will go to the deployment stage, and then it will enable the console. You can also see the metrics here, how much memory you use, like your project uses, as well as the CPU, as well as the response time. At the free instance, you might not get that much faster response time, although you will get a response. Don't worry. You can see it is saving the registry in a production directory. So let's wait for that. And as I said, it is adding a Heroku shim layer for Python. So let's wait for that. It will again start deployment in for like 2 to 4 minutes. Let's see. As you can see, the deployment is scheduled and it should work on the allocation and the networking of the deployment server. and it should start the instance. So yeah, the instance is created, preparing to start. First it will do some networking stuff and then it will start running the server. So let's say our server is currently situated in the United States, as we have given the parameter as Washington DC. So let's see what happens. Okay, so instance is starting. It is preparing the network configuration, as I said. It is unzipping the required analytical packages that we have given in our app.py, the Panketi tab and WordNet. So let's wait for that. Now you will see a warning, compiled the loaded model, but the compile metrics have yet to be built. Model.compile.metrics will be empty until you train. That means the model will not be having any training on the data you will be providing after the deployment. Currently it is empty, and if you want to train your model, it will require some tweaks in our app.py, as well as we would not have to import a .h5 model. We will have to import a Keras model. So it's no big deal to worry. So if now you can see the instance is healthy and all health checks are passing. So if we go to this URL, I'll just open it in a new tab. And if you go here, as you can see, we have our bot running currently. And if you just type hello, it will give you a response. See? And if I type bye, it will say goodbye, have a great day. That's it, guys. That's it for the app that you are going to build. So about the URL, if we come to services, and here, not here actually. If you go to services, then go to this 3 dots, then edit app, and then coep subdomain. So if I just say PyCart customer service chatbot and hit enter, it will now give me a URL, PyCart customer service chatbot, and my username, and then some stuff that it requires, and lastly a subdomain of coep will be applied. So if you go here, you will get the same bot. If you want to add a domain, you have to go to domains and then add a domain and then assign it to the service. I'll not do that since most of you will be using the free instance. So that's it for the deployment. Thank you. So there you have it. We have just walked you through every step of creating this chatbot. Make sure you like the video and subscribe to the channel if you have enjoyed this. And also click the bell icon so you never miss out on it. Thanks for watching. See you in the next one.